Guys, thank you very much. Give a clap for all of you. Okay. Just responding at very, I don't think I need. Oh, pardon. ஆமாமா. Where should I put this? Fine. So thank you for coming very short notice. What we are trying to do is that when scholars come in, we just want to see what is the level of how do they approach problem solving, right? And just by looking at an answer, we get a lot of insights about the understanding of the scholar about a particular topic. For example, let us say 2 plus 3 into 5, right? Somebody writes it as the actual answer is 17, right? But somebody writes it as 16. By giving more addition exercises, we can easily find out, okay, we can see that the scholar can, the student can improve. But suppose he writes it as 25. That means he has not understood the precedence of operators, right? So he first adds, he or she adds 2 plus 3 and multiplies by 5, which is wrong. So that's a much more conceptual difficulty that the particular student has. So just by looking at the answer, we can get a lot of insights into the student's understanding of the topic. And we are trying to do something close to this. This is just an experiment this year. And what I believe is that over a period of next 5 to 10 years, if we start looking at some of these problems and trying to solve and try to get some data out of it, this time we are going to get minimal data here. Well, if we get some more data into it, then probably by giving these questions and making the student see how the student approaches it, we can give very better advice and better guidance on how they could proceed on, a different level of thinking, right? And problem solving. Research, I need not tell all of you are all doing research. It's all about problem solving. And now what we have done is today we have around 3,500 students who are writing our PhD entrance exam. And we are giving them, each one of them, a question paper. So a batch of, we have split it into 6 batches, 5 batches plus 1 buffer in case there is some issue. So already 3 batches have completed. The 4th batch is going on now. And so each batch is given one question paper, which has 6 questions, which are slightly out of the box. Okay. And they write the answer and they basically upload it, and it's available in the Google Drive. Now I would request each one of you to take a bunch of, so we have so many people, so there are some around 500 students in a batch. So each one will get some 10 papers. We will now discuss how to evaluate it, how to grade it. I just want you to grade and put the marks in the Google sheet and add some comments, right? Some remarks about how they have solved. This will help so this will not be part of any selection, but when the student eventually gets admitted, this will give a lot more pointers to the respective guide and also to the student of where some points where they could improve, right? So this is the experiment which personally I wanted to do for last 20 years. Now that I have become director, somehow I managed to do it today. Okay, and thanks all of you for being part of this experiment. Okay, thank you very much. Now let us start. Okay, the first this is the first set of papers. So I start with this comment. Just go up. So this is what I have written here. I hope all of you agree. Dear friend, this examination is not proctored. But this is a statement. You are writing this exam as a part of the admission process to a research program at IIT MADRAS. We wish you all the best to become one among the most successful researchers, impacting positively the world that we live in. History has repeatedly proved that every successful researcher whose contribution is remembered and used for long has always been honest. Here is an opportunity to demonstrate your honesty. It's a very simple exam which will help us understand your strengths and weaknesses in analytical thinking. That will help IITM as a system to guide you better in the event of you getting selected. We are not proctoring this exam with a firm belief that you will maintain the necessary code of honest conduct and shall upload your answer script within the prescribed time. And all the students have uploaded, that much we know for sure. Okay, right. So this is what, so then there are some instructions, that's very simple one. Okay, so this is a problem. I want them to find what is angle ADC, right? So this is the, so I'll just give, so it is just, the issue is immediately you'll start calculating something here, here, here. But the thing is, you should start looking beyond. And sometimes when you start looking beyond, you get answers to some internal issues. This is actually a mindset that you can do, and how this problem gets solved. I'm sure this pen is not good. 100% sure, because the way I've written here. Can you get a good pen? Is it good? Okay. If you say it's good, it's fine. Okay. So let us draw this. So there is this. No, should be looking. Why don't you get a pen? Green works. No. Go and buy a pen and come. Get brand new pens. I think this deserves a brand new. I have to write for another 5 hours. Okay. We're standing. All of you have a notebook? Yeah, please take. So AB is 8 and your AD, there's a D here, and then I have a C. So this is 12 and this is 4 and this is 60 degrees and this is also 60 degrees. Please note that AC is not a straight line. So that's obvious, right? So AD, there's an angle there. So I need to find ADC. See, one of the things is there are a lot of clues given, right? This is size 8, this is 4, okay, and this is 12. These two angles are equal. So if I'm going to connect this line and this line, then those sides are going to be equal, right? So what I do is just extend this straight line and make this, right? And that becomes X, right? Good. If I extend this becomes 6. That means immediately you know that since this is both are 60 degrees, this is isosceles triangle. So you know that this is 8. Okay. So this is 60, this is 60, this is also 60 degrees. Okay. Fine. Got it? Now let us now draw one line here such that this is 4. Okay. Let us draw a line. This is 4. So ultimately, since both of them are 4, so we know that this is 60 degrees and this is 60 degrees. Okay. And hence this is also 4. Okay. Fair enough. Now let us draw, since this is 4, this has to be 8. Okay. Now if I am drawing this, right, if I connect these two, please note that this not be straight line, be straightly, it's not up to scale. So since this is 60, this is also 60 and this is also 60 and this will also be 8. So essentially this angle also becomes 60. Okay, because its total is 180. Okay, now between this A and Y, so now the next thing that we can do is just draw a line from this to the middle of this. Okay, let's draw a line from this to middle of this. Then what happens? So this is 8, right? So this becomes 4 and this becomes 4. So this also becomes 60. Okay, and this also becomes 4. Okay, this also becomes 4 and this becomes 60. So this is 120 because this is a straight line. So I draw this thing, right? So this is A, D, and M, and okay. And since these two are equal, this is an isosceles triangle. So this must be 30 and this must be 30. So the total angle now would become 150. So answer is 150. Okay. So the point is, if you just restrict yourself to basically handling this alone, you will not basically get anywhere near. The moment you just start expanding your horizon and try to extend this and use this facility. So what we did, we got X here and we know that this is isosceles. So 60, 60, 60. So I have all the sides same. So I have 8, 8, sorry, this and this side becomes, 8 and 8. Now with that, since I have a 12 here, I construct another triangle to get, I start trying to access parts of this by constructing multiple triangles. I am getting values for parts of this D, and slowly I am building it to basically get that, right? So this is how you do an incremental approach and you do something outside what you are already given and explore some simple properties. The three sides of a triangle as three angles, sum is 180 and isosceles triangle, simple properties of triangle, right? You got this? So, so, so if somebody, so when we start evaluating, if someone actually tries to get even one part of this angle correctly, right? We give them half the marks, like 5 marks, correct? Because he or she is now trying to see that they can't solve the problem in whole. They are trying to divide this problem and they are able to get parts of it correctly and they build it out, right? That's the approach. In research, what you do, you have a large problem, you can't solve it fully. You see some part can I solve, then I go to the next part. At least that initial urge, is it there? This is what we would like to get out from this particular aspect. Are you agreeing with me? Right? Okay. Fine. Okay, let us go to the second question. Yeah. So 10 power 200 E, okay, 10 power 200 E plus 10 power 201 F is equal to 2024. 10 power 199 E plus 10 power 202 F is also equal to 2024. Okay. What is E by F? Okay. So it's very simple problem. One second. Normally when you see this, people will look at it like a simultaneous equation and try to solve this equation. But the point is, it's not simultaneous equation because both are equal, right? If I have some two different things, then I can do some factorization. And some people will start looking at, okay, it's prime factorization or 10 power. So many things. But there's a very simple problem. What you need to do is just put 10 power 200 E plus 10 power 201 F is equal to 10 power 199 E plus 10 power 202 F. And what's common here? Smallest one is 10 power 199, right? So you just divide it by 10 power 199. So you get 10E plus 100F is equal to E plus 199 means what? 1000, 1000 F. Okay, so 10E minus E is 9E. 9E is equal to 900 F. So E by F is equal to 100. Correct? Right? Many people would have solved this. But some people, the point is, what does this tell? If some person is actually trying to solve it by putting some factorization, some coefficient, etc., just give some 2 marks out of 10. They try to attempt. Okay. Some give up is give up. Okay. But at least I'm trying to attempt. In research, you should never give up. Right? You at least attempt. So some attempt is there. And he or she is not intimidated by that power. Why we put all these 10 power 200 and suddenly, what? Big deal. Okay. Just to psych. That's the point. So I'm not giving up. Right? So attempt you give 2 marks out of 10. But then, suppose, then they should see this equality. And then they should see something common. So if they say this is equal to this, give 5 marks. Because they have seen the equality. In research, there's something you see. For example, there's a concept called simulated annealing, which came from mechanical engineering. And computer science fellows observed it and started solving very complex computational problem using a principle of mechanical engineering. So we are not going that deep here. But at least between two equations where I have explicitly told it's equal, people should realize that it's equal. If they have realized that it's equal, give 5 marks. Right? Then, of course, then I have to solve this real intelligence, a little more intelligence. But it's a very simple problem. Okay? But when just you give that, it looks a bit complex. Okay? Okay, shall I proceed next? So it's also there in the YouTube. So you can also verify it later if you are. Is this interesting, boys? Yes? Only few are saying yes. Okay, thank you. Yeah, Chula. You can use. This is one way of solving. Any other principle, you would have used that for the entire 1 hour, you should have solved only one problem. That much I am clear. Okay. But if they are using some other principle which you feel is correct, you please, you can give full marks. And anything close. So I leave it to. So what we are expecting from that question I am giving, I leave it to your discretion to do that, right? So, right? But anything else other than this, I also put these questions in ChatGPT. It's a big work, man. ChatGPT couldn't solve it, okay? So that's also okay. So this is real. Okay, just look at it. Then the next one is works. No, this also works. Okay. So see, these are now things that we expect researchers in a big way. See, AN is actually denotes the number formed by the last 2 digits of 7 power n. So A1 doesn't work. I'm telling you. This is new. No, this is not new. Camera தெரியலையா கண்ணுக்கு தெரியுது. Okay, fine. Okay, A1 is 7 power 1, so I get 7. A2 is 7 squared, which is 49. So I put, I say last two digits, right? Yeah, 49. So 0, 7, and this is 49. A3 is what? 7, 9, 63, 7, 4, 28, 343. So 43. A4 is 2401. Okay, so 0, 1. It becomes 0, 1. Again, when you multiply, so A5 again will get 0, 7. A6 again I'll get 49. A7 I'll get 43. A8 I'll get 0, 1, and this will repeat. So you just spend some 4, 5 minutes, 3 to 5 minutes on this, you get this very clearly. And now you see that every 4 terms will give you 100. Every 4 terms will give you 100. Now sigma I equal to 1 to k, this AI is what I put 50,600. Okay. Every 4 terms give you 100. So some 4 times of this sum, sorry, 1/4 of this sum, which should give me 506. Okay. Because every 4 terms gives me 100. So I just take 4 terms, so that this will give me uh, 506. So this sigma I equal to 1 to k AI. Okay, I need to find the value of k. Okay, um, is each of these terms will give me one. Okay, so each of these term is going to give me what? 100, 100, 100, 100, 100. Okay, so how many such terms will be there? There will be 506 terms. Okay, so so every 4 term is giving me 100. So that by this, so what would be k? K will be 506 multiplied by 4, because each one is contributing 4 each, and there are 506 such. So 506 into 4 is 24 this year. Okay. So this is the answer. So the main thing that we are trying to see is, if he is patient enough to actually go and find this. So attempt 2 marks you give, just attempt. But anything, there's no other solution for this except this. But as he's seen this, if he is able to come somewhere close to some periodicity, right? That's something obvious, right? For solving a problem like this, if they are going to see that periodicity, that cyclic nature here, then give around 8 marks, and the correct answer give 20, 10. Okay, so this is a very sort of interesting problem. Yeah, the point is, the attempt here essentially means that he sees that there is, this comes as 7, 49, 43, 1. You may not add it and make it 100, but at least see that is coming as 749, and then at least A4 is 1 and A5 is 7. That's what we mean by an attempt, right? So we can give 2, but if he comes very close to this of finding the periodicity, that is the most important thing. Answer to chod do. Answer somebody will correct. When you write a research paper, finding the basic concept is important. Then some referee will come and tell you whether it's correct or not, and you can revise it. Okay, so that's the crux part. Then that you give, if they finish that, give 8 out of 10, and if they get the answer, you can give 10 out of 10. Okay, so this is the, let us come to fourth question. Fourth question is somewhere, right? 5a squared, 12b squared, 23, 20ac, 12bc. Now, when we get such type of questions, the main thing that we need to study here is what is it that I can play with? The thing that I can play with, see, there's also a C, but I'm asking about A by B. Only thing I can play with is they are non-zero real numbers, A, B, C. So I can play it only the coefficients. And I see some patterns. There are some, or the first thing I have to do is there are some odd coefficients, there are some even coefficients. And there is something phenomenally bigger, there is something small and large. So this is something, this is the way, this is something that we can rewrite things, right? We can rewrite things. Can I bring it to some closed fashion? For example, can I write this as 5 into a squared minus 4ac plus 4c squared, okay, plus 3 into 4b squared minus 4bc plus c squared, and this is equal to 0. What I've done, I've basically used some of this 5a squared and 20ac are here, and I'm trying to bring a 4c squared. And how did I manage this? Because I want this in some square expressions. Okay, so you can easily see that this is 5 into a minus 2c squared plus 3 into 2b minus c squared. This is equal to 0. And note that they are all non-zero real numbers. So every word is very important when you write theorems. It will be so precise. So if this has to be 0, please note that a minus 2c must be equal to 2b minus c must be equal to 0. This has to be 0 and this has to be 0 because these are all positive. This square, again, this will be positive. So this has to be 0. And that essentially means a equal to 2c, that means a equal to 4b. So a by b equal to 4. Right? So this gets the answer there. So the simple trick here is what we want is does the candidate try to bring it into some closed form. This attempt would vary 50% of the mark. You got it, right? I can give 50% of the mark if it's trying. See, sitting in an examination in in that tension, probably I may not be in a position to basically get into this very close form, but at least I am trying to bring it into some tractable a plus b squared, c plus b squared. So that's something which we need to exploit. The second thing is that using these facts like non-zero real numbers and trying to see that if this sum is equal to 0 and I have a perfect squares here, so this is our positive number, and this can become 0 only if this is equal to 0, right? So that is something is a next order. So if they have gone up to this level, then it can be 10 marks, of course, but if they have just stopped at that level, they have even tried to do it, give 50% of this. Okay, right? See, if a similar examination is given to me by somebody who is setting such papers, I would only score, say, 30% out of. Scoring 30% out of 30 out of 60 itself is a big deal, right? So that's the stuff. But what we are trying to see here is we are trying to get to understand more about the way person has thought work. Okay. So last one is pretty slightly and very interesting problem. Yeah, just go to the Rudrang. This one? No, no, this one. Mouse is okay. Oh, last but one. In 1970, the ages of father and mother of a family were 33 and 28. They had 4 children, 7, 5, 4, 1 in 1970. The family of 6 is still living in the year 2023. Now let P be the sum of the ages of the parents every year, and C be the sum of the ages of the 4 children every year from 1970 onwards. In how many years from 1970 to 1923, 2023, the difference between P and C is a prime number. What question? Okay. So what is the difference? P minus C or C minus P? So this absolute of the subtraction of one to other. Okay. Now see, this problem looks very tough, but it's very easy. Actually, if you take this, P is 33 plus 28, which is 61 in 1973. Okay. And C is what? 7 plus 5 plus 4 plus 1, which is again 17. So this is also odd and this is also odd. Okay. So the difference between two odd numbers is going to be always even. So what is the only prime I can get here? 2. Okay. So what are the possible answers? Minus 2 or plus 2. So what are the years where they will get minus 2 or plus 2? So first they start 61 minus 17. So every year what will happen? 1974, right? They said 1970, right? 1971, what will happen? This fellow will become 63 because both of them increase by 1. This fellow will become 2019. 21. So there will be so what will be the difference? Difference will be 2, right? So the difference will the difference between this will increment by 2. Every year it will increment by 2. So so what will happen? First year it is 44 is the difference, right? 61, 40, yeah, 44 is the difference first year. Next year it will become 42, then 40, 38, 36, 34, 32, 31, 30. Then it goes on. So this is 1970. So when I say 71, 72, 73, 74, 75, 76, 78. So 28, like that, this comes down. Okay. So I can say this is 1, 2, 3, 4, 5, 6, 7. 30. Sorry. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 years it comes down by to 26. So so what is so every year it comes down by 2. So by when it becomes 2, 1991. This is basically I have to, from 44 it is coming to 2. That means I need to reduce it by how many? By 42. 42 is by 2 is 21. So 21 years it will become. Then it becomes 0. In 1992 it becomes 0. 1993 it becomes minus 2. So 1991 and 1993 are the answer. Okay, got it? So first and foremost, this has several steps that we can analyze. First and foremost, attempt analyzing that these are odd and the difference is always going to be even. And when the difference is going to be even and integer, the only primes are 2 and minus 2. This is one thing. So this warrants 50% of the marks. They just get this, that's 5 marks. And after that, if you see, then all, if they are able to, then it's quite straightforward. If they are able to get somewhere close to 1991, 1993, that range, give them 8 marks. Exactly 1991 and 1993, give 10. Just 1991, give 8. Okay, but then in 1991, 1993, you can give 10. If close to 1991, 1993, give 7. So give some credit for coming to grade. But they should realize that there are 2 halves to it, plus 2 and minus 2, right? So that's also very important. So these are all attention to details. So it's all about grading, right? Easy to get B, but then you want to go to A, right? Little more care. If you are really S, then you need to put the full care. Correct? So this is what. So it also comes with the way we grade in our courses, right? Able to understand this? Yeah? Okay. Ah. Oh, in 21 years and 24 years. Correct. In exactly 2 years also. 2 can also be the answer. Sorry. Okay. Correct. Very good. So it can be 2 can be the answer. They can also say in 21 years and 23 years they can they'll meet the prime, or they can give you 1991. Fair enough. Very good. Okay. Yes. The last one. What is the 100th term of this? See, so I'm writing this one. So I've actually even enumerated this. So all the 10 digits are written in ascending order. So of course it can't start with 0. So 1, 0, 2, 3, 4, 5, 6, 7, 8, 9. Just forget. So just write till 1023. This is what we are expecting. Just write till 102345. With the 6, 7, 8, 9 combination, we can get 24 of them. Correct? Permutations. 4 into 3 into 2, 24 of them. Then the next one would be 1, 0, 2, 3, 4, 6, and I will have 5, 7, 8, 9, which are again different combinations, and I'll get another 24. Then I do 1, 0, 2, 3, 4, 7, and then I put 5, 6, 8, 9, I get another 24. And 1, 0, 2, 3, 4, 8, and I put 5, 6, 7, 9, I get another 24 combination in ascending order. Okay. So what will be this number? 1, 0, 2, 3, 4, 8, 9, 7, 6, 5. Is this 96th number? Okay. So what will be the next number? 1, 0, 2, 3, 4, 9. Okay. And it will be 9, 7, no, sorry, 5, 6, 7, 8. To the next number. Okay. Then this is the 97th number. 1, 0, 2, 3, 4, 9, 5, 6, 7, 9 will be 5, 6, 7, 8, 5, 6, 8, 7. Sorry, 5, 6, 8, 7 will be the next number. Then 1, 0, 2, 3, 4, 9, 5, 7, 6, 8 will be the next number. So 1, 0, 2, 3, 4, 9, 5, 7, 8, 6. This is the 100th number. Right? 97, 98, 99, 100. 1, 0, 2, 3, 4, 9, 5, 7, 8, 6 will be the 100. Okay, the main issue is that the whole thing that we want to test here is that you give a problem like this, are they able to break it down into some smaller sub-problem and handle it? Correct? I just took this first 5, 6 digits and the remaining I got 24. And I keep repeating this, so it become tractable. So when you take a large problem, can you split it into small problem and make it tractable? This is what we want to test here. Right? If somebody starts writing all the 100, it will take 45 minutes exactly. Okay, so without mistake. Okay, so that's the thing. Okay, so this is what we. If they get the correct 100 number, fine. If they are trying to do something like splitting this and trying to do some divide and conquer, whatever form, give them 5 marks out of 10. That way, then full you can give 10. Okay, these are the 6 questions. I hope you enjoyed this session. Okay, and what I'll do is I have this answer script. That will be sent to you by WhatsApp. The question paper also will be sent to you by WhatsApp. Then you can go wherever you want, to a hostel or here or anything, and then they can take it forward.
Some announcements. Basically, we have sent the sir told we have sent the question paper and then answer sheet to the WhatsApp group. There are also a video link that has been shared in the WhatsApp group. In case if at all if there is any doubt, he can access it. To know who are the students that you have allotted, you need to go out. There will be 6 people. You need to stand in 6 equal queues. You need to tell them like your name and your phone number and then your roll number. They will allot you 10 to 12 answer sheets for everyone. And then we have also shared the Excel sheet where you can in real time you can go there, you can see the Excel sheet, and then you can know like with to whom you have allotted. And then once you have corrected everything, you will be given a Google form, and that has also been in the group, been put up in the group. You can go and then you can put the roll number of the student and then the mark and then few comments and then you can close it. That's it.
For each student, I will be grateful if you can put a comment there. Depending on our discussion, if you can put a comment that okay, it went so much, did not. Okay. Thank you very, very much. And looking forward. Hope you all enjoyed. Hope it was interesting. Okay. Thank you.
I'm so sorry that we don't have any room right now here. You can go to your hostel or lab to correct the papers. First and foremost thing that you need to do is go stand in queue, give your name, roll number, and phone number, and then move out.
Just another request. I request all the Team 1 TAs to go out and get your allotment first. Super TAs can stay back.
Ah.
Some government jobs. So they are given to all of the 10%. So sometimes they have directly answered.
Yeah. But we said very clearly you should give.
Check what
Don't give marks because he said very clearly. Yeah, every question attempted, please give detailed explanation on how. No, but it's very difficult to direct. I don't think it will be easy. Sure. Huh? Huh? No, they can try. They can. We are not anyway taking it as. Many things are. Nothing is no formula is used. Okay. But still, it is no, we are not going to use it for any selection, but we will basically have this as a pointer. Right? Wait, there's no max here. No? Yeah, I understand. No, that's right. But we are not actually using it as part of selection. We are just missing. Okay. 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 Understandable. So we are very clearly told that. It's not you're not going to use it as a part of your selection process. Don't feel bad about it. Um, mm. We'll try it out next year. We'll try it next year. We'll try it next year. But for somewhere again, it's all lot of things are coming as data also back to you, right? So some analytics is coming. Okay. But for engineering students, okay. Only for money. Okay. Yeah? Yeah. Okay. So we'll make it more for the HS. We'll make it one. But this is all logical reasoning. There's a lot of logical. There's a lot of logical reasoning. Right? Aptitude, yeah. This is what is needed for engineering. Almost. Yeah. Yeah. Huh? No, no, I said no. Okay. Yeah, yeah, sure, sure. Okay. Very interesting. We will see. This time we will see what has happened. But anyway, we are not going to use it for part of selection, for surely for HSS. We will see what has happened. What is it that they have done? We are not shortlisting based on this and all. But we need to get an understanding. Suppose someone has done well also. Then they can go on to some digital content of HSS. There are some people like, yeah, yeah, later. That we'll do for HSS next year. Next year. Fair enough. Fair enough. Yeah, yeah, sure. Sure. Come, next question. So after this, I want a logical break. Physical break. After session, I'll just have 15 minutes and then come back again. But this blue pen is not working properly. So, okay, I'll do it. I don't understand why blue is seen well in the video and not black. Okay, friends, thank you very much for coming on a very, very short notice. What we are trying to do is to conduct an exam where we put certain questions which use some basic mathematics, not great mathematics, some basic 12th standard, 10th standard, 12th standard mathematics, compound it with a lot of logical reasoning to finally see if we can understand where the student, what is the orientation of the student when it starts approaching a problem. Okay, it's not going to be part of any selection criteria, but this will give us some input about the student. So in the event of the student, when they get selected, we would like to see whether the guide and the student can sit and discuss this particular thing and see where where they could strengthen themselves in terms of doing high-end research. So this is the overall view. One immediate feedback I got from HS is this is not really what HS would want, but this is more for the engineering students. And but anyway, this all there is a lot of logical reasoning compounded with a lot more of mathematics that we are trying to bring in here. Okay, so this particular exam I have started the experiment. We are trying to do today. More than 3,000 students have taken this exam today, and we would like to evaluate them. And as part of evaluation, it's not going to be the a binary evaluation whether they got. We are getting out of this what do you call this MCQ business. It gives nothing about how the answer was arrived or not. We are now going through how the student has approached. We have requested the students to actually write the detailed just process by which they have approached the problem, and based on that, we would like to understand the student's attitude or the student approach to problem solving, right? So, so this exam I just gave for all the super TAs. You are there, be repetition, but we all started off. This is a very interesting thing. Suppose you ask what is 2 plus 3 into 5, and if a student answers this as say 18, I can give more arithmetic and fix the problem, because they actually calculated 15 plus 2 17, but something wrong with their addition. But if the student has answered this as 25, there is a conceptual error because he has added first and then multiplied, while he should have multiplied and then added, right? So by just looking at an answer, we can certainly get a lot more insight about the understanding of a particular concept by the student. And this is precisely what we are trying to attempt here. This is an experiment. So thank you very much for volunteering to help us out in evaluating these scripts, right? So this is a second session today, and we have a set of problems so can we just go up? Right. I'll go. So we want to find, so there is a triangle with there's a 70 degree here. This is This is not a triangle, but this C, then there is an inclination, and this is 170 degrees, and we want to find out this angle DAB. Okay, right. So again, if you start dabbling with this, and these are equal, so AB is equal to BC equal to CD. Okay, these three are equal, and you just start dabbling with this, you never will find the solution. The easiest, the way this need to be solved is I'm just drawing this here. I have A, B, C, and D, and this is 170 degrees, and these three are equal. DC equal to CB equal to C. Now, the thing that we can do is that let us just draw the bisector of this, and let us draw the bisector of this, and they will meet at some point here. Okay, so this will be 35 degrees, this will also be 35 degrees, and this will be 85 degrees, and this will be 85 degrees, and let us connect this. Okay, and let us connect this also here. Okay, so this is a part. Okay, the moment we do this, please understand that these two sides are equal, these two angles are equal, and this side is common. So this triangle is basically congruent to this triangle, correct? Immediately. So essentially this part becomes 85 degrees, and of course this is basically 85 plus 35 is 120, so this becomes 60, this also becomes 60, right? Right? Now, when we look at these two triangles, please note that these sides are common, this side is common, and this triangle and this triangle. So this is common, one angle is, this side are equal, this angle is common, and one side is common here. So these two are congruent. So what happens is that this becomes 60 degrees, and this becomes 45 degrees. Okay, sorry, 35 degrees. Okay, that's a 2, 2. Now you see that this total is 180 degree. So essentially this is a straight line. Okay, these are collinear. So the answer for this would become what? 85 degrees. Huh? You are not able to see? So when you look at this, this becomes 180 degrees. So this becomes collinear, meaning it's a straight line. So the answer is 85 degrees. So this is a solution. So first and foremost, what are we trying to basically establish here? For someone to get this answer might be difficult. Some could have got this answer. But the point is, the first thing that we want to evaluate is this angle DAB cannot be computed as a single piece. We would like to see if there is an attempt to try and get part measurement of this DAB. That's what we are trying to do, right? So we are basically trying to see if I could get some isosceles or some congruence relation and try to estimate part of it. Ultimately, it turned out that this part is actually full, but we were actually trying, we never knew that this bisector of these two will meet in this line. It is meeting, we just assumed that it is another point and not on this straight line between D and A. It actually happened to be on D and A, right? So if there is an attempt to get part of this angle evaluated or calculated, we give them 5 marks out of 10, right? But then if then they start doing, since we have only angles, we don't have sides except that they are equal, they have to start playing with angles, and the only thing that I can play with an angle is to bisect it. Nothing else I can do with an angle. Okay. So when will I try some bisecting and see? So that's the next step. Okay. So 5 marks given, even if they try to attempt to see if they could split into, and that essentially means from a research angle, if given a problem, they have understood that problem and they are putting a right approach. Finally, there will be a guide. There will be referees who will finally say this is correct or wrong. But then we are now at least going on the right approach. The student has an attitude to do that, and that's what we are trying to evaluate. Okay, fair enough. Okay, so next. Okay, now this is a very simple logical reasoning question. So a maths teacher wrote 5 consecutive numbers, natural numbers on the board, and asked the students in her class to find their sum. Okay. So one of the students copied all the numbers correctly except one number, where he copied only one digit wrongly. Otherwise, he calculated sum without any error and got the results. Okay. And that result is 2023. He got 2023. If the sum of the digits of the number copied wrongly is 6, there's one number he has copied wrongly in which one digit is wrong. And the sum of the numbers, sum of the digits of the numbers copied wrongly is 6. What is the actual correct number that should have been copied? Okay. So this is the question. First and foremost, this requires, since see many times when you say 5 consecutive natural numbers, 6 numbers, so that then anytime you get something like this, then the inclination must be to enumerate and see, right? Even in research, right? First, when you want to build a large scale system, take a small case and enumerate that case, exhaustively enumerate that case. And if exhaustive enumeration is going to cross your 10-minute barrier, then don't do it. But these things can be done. So first and foremost, if you say let us just take out this 1 plus 2 plus 3 plus 4 plus 5. What is this? This is basically 15, right? 5 plus 4, 9, 15, right? Now, when I do 2 plus 3 plus 4 plus 5 plus 6, I am adding 1 and I am subtracting, I am adding 5 and subtracting 1. So I'll get 20, correct? 5, 9, 9 plus 5, 14 plus 6, 20. When I say 3 plus 4 plus 5 plus 6 plus 7, I am getting 25 because I am adding 7 and removing 2. So always when I add any set number which is 1, 2, 3, 4, 5, every time when I add, I'll get either a multiple of 5 or a multiple of 10. So the last digit will be either 5 or 0, always. You're getting this? Now, this fellow says that this is the first thing. I'm getting an answer which is 2023. That means he should have messed up which digit? The last digit. So that's the first inference. Okay. So if somebody is able to do this much, okay, that is this is all multiple of 5, that itself warrants at least 4 out of 10. 40% marks. The sum of the 5 digits is always the natural numbers will end with a 5 or 0. The next inference is if it says that, okay, now I am getting 2023, I am messed up on the last digit, that warrants at least 2 marks out of that. Right? So if I am messed with the last digit and I have 4 consecutive numbers, so 5 consecutive natural numbers, then obviously it has to be something with 400, right? Because 400, 400 will into 5 is 2000. So I can't have anything above 400. So what is and this is last digit is messed up. So if the last digit is messed up, so I will be anywhere between 10 below this or 10 above this. So my answer should be somewhere either 2015 or 2035. Okay, I can go maximum to either because the last digit is messed up. So I can be either 2015 or 2030. So what are the numbers that will give me? 401, 402, 403, 404, 405 will give me 2015. So it will be 402, 403, 404. All this will give me 2015. Anyway, 2030 only, because 2035 is 10 away. Okay, so 2015, 2020, 2025, and 2030. Okay, so these are, so the first number will either start with 401, 402, 403, or 404. If this is done, we can certainly give 2 marks. Right? Correct? So this is a very interesting observation, because my total should be 2000, around 2000. So I can't cross the 400 limit. I can't be less than the 400 limit. Correct? And what is, and since last digit is messed up, I can be 9 before this or 9 after that maximum. So this is 2015 to 2030. And these are the only 4 combinations that can be. Okay, is fine. Now the last one is we want 2023 from this, right? So the 2023 can come. I have to only one digit I have changed. For me to get 2023, I have to add only one digit I change, means I have to make this 409. Instead of 1, if I put 409, I would have got 2023. Right? But I said that the sum without any error and got, if the sum of the digits of the number copied wrongly is 6, this is not adding to 6, this is adding to 13. So this is not the case. Now this 402, 403, 404, 405, 406, this has to become 2023. Means some 3 has to get added. So how do we do that? So I can add this can become 405, 402 can become 405. That's wrong, because I'm not getting 6. 403 can become 406. That cannot happen. 404 can become 407. 405 can become 408. 406 can become 409. All these cases cannot happen because sum is 6. Sum is 6. It's not meeting. Now let us take 403. In this case, 403, 404, 405, 406, 407. So if I this 2025, right? I have to bring it down by 2, right? So I can make this by 2. 404, if I bring it by 2, then I get this 6. Okay. So the actual number that should have been copied by the student should be 402. The same you can now try on 5, 6, 7 and all, we can't get it. Because 5, this will all become 9 and above. So this 6 will not. So the actual number, instead of 402, 404, he has copied it as 402. That's the answer. So if this step they get, we give them 2 more marks. Okay. So the point is, this is a very difficult one to arrive. Okay, I agree, right? To come to this stage. So you give a lot of marks for even this approach. We basically want to look at the way people have approached this problem. Okay. Right. So then the third question. PQ 3P plus 4 or a Pythagorean triplet, that is ABC is a Pythagorean triplet, means A squared plus B squared equal to C squared. So 3 squared plus 4 squared equal to 5 squared. So the general Pythagoras theorem that we see. Now the value of so PQ and 3P plus 4 are Pythagorean triplet, and P is a prime, and the value is less than, each has a value less than 100. So what is the value of Q minus P? Is the question. So we know that 3P plus 4 squared, that's the last one, is equal to P squared plus Q squared. So this minus P squared is equal to Q squared. So 3P plus 4 minus P into 3P plus 4 plus P equal to Q squared. Sorry. 3P minus, no, sorry, Q squared. Minus Q and plus Q. Sorry. Because P is prime. So I try to retain prime here. Okay. Right. Now please note that 3P plus 4 plus Q is greater than 3P plus 4 minus Q. Okay, for sure. And since P is a prime, what are the factors of this prime? 1, P and P squared are the factors. See, prime number, if I have P is a prime, then for P squared, P into P is a factorization, but P cannot be factorized further. So if P is if 9, 3 is a prime, what are the factors of 9? 1, 3 and 9. So that's the thing. So 1, P and P squared are the only factors of this. So, okay. So this essentially means that if this should be correct, 3P plus 4 plus Q should be equal to P squared, and 3P plus 4 minus Q must be equal to 1. Correct? The only way I can do this. Because this and this are not equal. So both cannot be P to get P squared. So one has to be 1 and another has to be P. And this is lesser than this. So this will be 1 and this will be P squared. Sorry. Okay. So very quickly we can see that just add this, very nice. So 6P plus 8 is equal to P squared plus 1. So P squared minus 6P minus 7 equal to 0. So I have P minus 7 into P plus 1 equal to 0. So I said it's a prime number, so P equal to 7 is the answer. So if you just put there, and then we can substitute back, since now we want Q minus P, Q minus P, P equal to 7. So Q equal to Q equal to 3P plus 4. Yeah, Q is equal to 3P plus 4 minus 1. 3P plus 3. So this will be 21 plus 3, 24. So Q minus P is equal to 17. Right? And you can substitute P is equal to whatever 7 and Q is equal to 24 here. 7, 24 and 7 3s are 7 and q equal to 24 and 3 7 21 plus 4 25. 7 24 and 25. This is a Pythagorean. 7 squared plus 24 squared is equal to 625. This is 25. Okay. Then the fourth question. Just go. So there are multiple steps. First and foremost, if this is written itself, right, where I have P on one side and I am analyzing everything with respect to a known value which is prime with a known property, please give 5 marks for this itself. But then all the other analysis, if they are very close to what you are getting, so only answer. If they are close to give the remaining 5 marks. Okay, so this is how we. But this is very, very important that what we are trying to find is if there is a known parameter, I would like to handle everything around a known parameter. So in research, what happens normally, we start looking at some parameters which are unknown and try to get unknown from unknown. That's going to be difficult. You're getting this? We have to get we have to have known, and everything should be centric around that known, and see how we derive that. And that's very important for research. So this is something that we can find out explicitly. Just this step itself, that I'm going to get my control with P, and this is the only thing I can, the immediate thing I can do. At least that step is taken. I think that warrants 50% of the marks. Okay, right? So next is this is a very actually a very simple question, quite very some observation to details. Many times in research we want some minute observations to details, right? And this is one question that will basically get this. First and foremost, I want what are the missing digits here? Okay, so I want a 4. So obviously this should be 2, because 7 into anything else will not give a 4 as the first digit. So I have 2 star 7 star 1 star. So the moment I put this as 2, okay, this is missing digit. So this will become 500 and 2 7 14 414, correct? Yeah. 430. Sorry, 434. Correct. I get 2. I know that this is 2. I don't know what are the other things. Okay, so so I'll get 2 7 14, but then I don't know that this is. So first I will fix this as 2 for sure. Now the next, since I have 1 here, sorry, yeah. So second one is star 1 1. Okay, star 1 star. Wait. So if I want this fellow to be 1, then what should this be? 217. So if I'm putting this 1, I have to want a 1 here. So I have to, this has to be 1. Okay. The moment I put that as 1, so this becomes 217, and this will become 434. Okay. Okay. Now I have star 5 star star. Okay. This is what I have. So so if I want a 5 here, so anything I multiply here, right? The 1 digit. If I multiply by 1, I'll get only 1 in this digit. If I multiply by 2, I'll get only 2. 2, 7, 14, I'll get 3. If I multiply 3, I get 5. If I multiply, if I multiply by 3, I basically get what here? 3 sevens are, no, 3 sevens are 21, 2 3 ones are 3, 5, 3 twos are 6, I get 6. See, that third digit is what I'm looking at, right? And anything up to 3 or even 4 doesn't work because I have one more digit left here. There's a digit here, it's non-zero. So it should be 5 and above. When I multiply with 5, I'm not getting 5 here. When I multiply with 6, again, if you just calculate, you will not get 6. So I have to multiply with 7. If I multiply with 7, then I get 7, 7, 49. 7, 1, 7 plus 4, 11. 7, 2, 14 plus 1, 15. Okay. Then I have 8 and 9. If I multiply, I will not get 5 here. Now add all these things. 8, 10, 14, 21, 25, 27, 34, 43, 44, 45. Answer is 45. Correct? No, no. 434, 217, 1519. I missed something. Here. Okay, correct. 2, 3, 10, 14, 17, 21, 28, 30, 39, 40. What will sorry. So when you add this, there'll be 154504. Sorry. And then there are 4 more here. So ultimately you should get 56. That's the answer. You'll get 56. That he's starting at 5, right? Yeah. Fine. Okay. So this is 56 is the answer. So you can just see some partial digit filling. So I saw that there are 10, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Forget this at least. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So if they fill 10 of it correctly, give 10 marks. Because the other thing would be. Okay. Right. Next. S is a 18 element subset of the first 20 positive integers such that the sum of all the elements of S is a multiple of 4. Okay. How many such possible subsets S are there? Right. Okay. So, what is the sum of the first 20 numbers? 20 into 21 by 2, right? Twenty into 21 by 2. What is this? 210. Is 210 a multiple of 4? No. So, if I want 18, I want some fellow who is going to reduce either 6 or 2 from this. So, if I take all the 20 numbers, I get 210. If I want a multiple of 4, then at least, I should remove some numbers which will reduce the sum by either 2, reduce by 2, right? Then we get the thing. So So how do we do this? So this is the first thing. So first step is something which we need to get. So if somebody attempts this, we should give them 4 marks for this. First they say, hey, this is 210. So I must get around this. So 210 becomes my anchor. And all that I'm going to do in this problem is centric around 210. Right? So, and it's a very simple one. I think anybody should know this. So that is the first thing that we can look at. And now, if we say this, so let us say, so it's all about multiples of 4, right? So we basically, since it is all about multiples of 4, we just basically say, we say 1, 2, 3, 4. When I divide by 4, I get a remainder of 1, I get a remainder of 2, I get a remainder of 3. So I can basically view this entire set as this much, okay, as 4 classes, because it's all about multiplication. So this will give me a remainder of 1, this will give me a remainder of 2, this will give me a remainder of 3, this is a remainder of 4. Okay. Okay. Now, so what I need to see is, if I am removing 2 numbers from the set whose sum is 2 more than a multiple of 4, because we have 210. If I remove 2 fellows whose sum is 2 more than a multiple of 4, the remaining fellows will be a multiple of 4, because totally I have 2 more than a multiple of 4. I have 208 plus 2. So if I remove 2 numbers whose sum is 2 more than the multiple of 4, then that remaining 18 will be a multiple of 4. Agree? Correct? So that's a very subtle observation here. So I need to remove 2 numbers such that their sum is 2 more than a multiple of 4. Okay? And all are distinct. Okay? So if I add numbers within C1, if I am adding 2 numbers within C1, say 1 plus 5, it gives me 2 more than a multiple of 4. So I can have how many combinations within C1? I could have 5 choose 2. 5 choose 2 is how much? 10. So I have 10 combinations from C1. Okay. Then let us say this one from C2. If I add a number from C2, these are 2 plus 6, 8. This will all be multiple of 4. So nothing I can add from C2. But when I add numbers from C3, 3 plus 7, 10, 3 plus 11, 14, because it is giving a sum of 3. 3 plus 3 will be 6, which is 2 more than 4. Okay. So I will have another 10 combos from C2, from C3, sorry. Right? Then I can't have one from here and one from here, because I need 2. Answer should be an even number. So this is the odd and this is an even. I can't have that combination. But if I add one from C2 and another from C4, right? Like 2, 4, 2, 8, I again get, because it gives me 2 plus 4 is 6. So how many combinations are there? For each I have 5. So 5 into 5. I have 25 combos from C2, C4. So totally will be 45. Answer is 45. I can't do, I'll do only with C1, only with C3, done. C1, C2 not possible, C1, C4 not possible, C2, C3 not possible, C4, C3 not possible. C2 and C4 possible, within C2 not possible, within C4 not possible. So we have covered all the combinations, correct? So by this we say that 45 combinations are there. If I remove those 45 combinations, the remaining 18 will be a multiple of this. So I'll have, the answer is, the total answer for this is 45. Right? Okay. So last one is this is again basically simple observations. So the evaluation for the previous question, that 210 warrants at least 40% marks, and then you start putting into this buckets because that warrants another 4 marks, and then this analysis is 2 marks. So total 10 marks. Analysis, that C1 alone, C3 alone, C1, C2. This is okay. So last one for this part is x plus a into x plus b into x plus c is equal to x cube minus 8x squared plus mx plus 42, and we want the value of m. First and foremost, please note that ABC should be equal to 42. Simple. ABC is the only constant. See, we need to now match the coefficients. The first, if you see that ABC equal to 42, please give 5 marks. Okay, because the approach is correct. It's trying to match the coefficient. That's what we need. And finally, answer whether it comes or not is a different question. After that, it's all jugglery. The approach is correct. ABC equal to 42. That now let us see. X cube is 1 1. What will be x squared? X squared, if you just see, will be a plus b plus c. Right? If you just expand this, it will be a plus b plus c will be x squared, and that is minus 8. Right? And if you see x, that will be ab plus bc plus ac, and that will be m. Now I have two equations, ABC equal to 42, a plus b plus c is equal to minus 8. Okay. If you reach this, this is another 2 marks. Okay. Now this is where the whole thing. Now suppose I write that a plus b plus 42 by ab equal to minus 8. That's all I'm gone. Never get the answer. Okay. So that's where many times you go into more analytical rather than a little more experimental. Many times experiments will give you better clue of how to solve the problem than going in a pure analytical mode. So this is gone. This is something that you should know, that this somehow comes very close to a Diophantine equation, and these are something which cannot be solved. Okay. So at this point is where you start using certain empirical. See, the moment if you start enumerating things, that means, in my opinion, this is a scholar who will basically come to a stage, and when it gets stuck up, will immediately quickly go into the lab or start writing a code or start working with some chemical, see some reactions. You got? So this is something that we would like to see, right? So this is my sort of expectation from this. So now you see, now your ABC must be 42, right? So, and ABC are integers. So what are the possible values of A, B, and C? So I can have 1. I can have 21 into 2 into 1. Okay, I can still have 21 into 2 into 1 is 42. Then I could have 3, 14 into 3 into 1, and then I could have 6 into 7 into 1. I could have all these things. Okay, or I can. So these are all the factors. So this factorization is very, very important here. So 1 in 2, 3, 6, 7. So this, the moment you get into this factorization, you know that this is minus 8. Okay, So that must be, and this is positive. So I must have two integers. So the answer will be, so what are the things? I can have any three combinations, -1 into -6 in -1 into -2 into 21. I will not get that -8 answer. So the only combination that will work here is 2 into 3 into, 2 into 3 into 7. Okay, that will work here. 2, 3, -2, -3 and 7 can work from this, right? -2 into -3 is 6 into 7, 42. Uh, sorry, 2, I can put minus anywhere, right? 2 minus 3 minus 7. This will work, right? Because I need 2 minus. So 2 into 3 into 7 is 42. Or 2 minus 3 minus 7 will get you minus 8. So that's a simple jugglery you should do after this. So after this part, they go into a cycle, that's done. But if they can come to this part, then they have excellent thing that for research. Okay, so that we give that full 2 marks more to get that thing. Okay. Okay, so this is it. Hope it's interesting. You feel? So let us try. So this is an experiment. We are not using this for any shortlisting or anything. Huh? Huh? What is M? M is okay. AB into BC plus AC. Okay. Now we can. Yeah. So -2 into 2 into -3 is -6 plus B into C is 21 plus 2 into -7 is -14. So 1. Okay. Answer. Sure. Okay. Thank you very much. Yeah. Rudra,
Thank you. One second, boss. We didn't finish. Sir, excuse me. We didn't finish. Here's some in-house announcements. So, there is a link which I have shared in the group for answer sheet. You need to go to that link. You'll find the answer sheets. You need to go to the session 2 folder to find all these answer sheets. To know whom you are allotted with, you need to go out. There is a table. There is a series of 5, 6 people. You need to stand in queue. You need to give your name, roll number, and phone number, and then they will allot you to a serial number. And there'll be an Excel sheet which I'll be sharing it in the group as well, so that you'll know what which answer sheet you need to you need to correct it. You need to evaluate it. Once the evaluation is done, you can go to the Google form that I have mentioned in the group. Go to the Google form, and then you can update the marks, and then you need to update the comments. If at all, if you want to do some, tell some comments, you can do that, and then you can just finish the process. Yeah. Also, there are a few refreshments have kept outside. You can have it.
All the super TAs here would be allocated to session 3. So kindly stay for the next session. Only the super TAs. Thank you.
I'm giving you at 4:45. 5:45, 6:45.
Yes,
Cut off time is 6:45.
for what I know, but this QA and all things will take time. So by 7 you are taking to some.
Yeah, it takes some time. From now, you can take 2 hours. 2 hours.
That is important. At least some step they would have done. Yes. So that's what they are saying. The whole exercise, we are actually giving marks for steps. The final answer is not of interest. Yes. Only the nothing. These are already shortlisted. Already shortlisted for it. So come.
15 minutes.
Go for a half an hour today.
Yeah, sure.
So half an hour. The 3 and 4, right? All have come. Just a minute. We can start. All have come in. So again, thank you very much for coming at a very short notice. What we are trying as an experiment is to basically understand for all the shortlisted candidates who will be attending our PhD interviews. We are trying to understand by this particular exam how effectively they are in approaching to solve a problem. We are not actually looking for correct answers here. If they get a correct answer, well and good. But is their approach proper? Are they trying to, come to something which is reasonable given the time limit, or they are just going away? So this particularly after the shortlist, after you get admitted, then probably the allotted guide and the student can sit and discuss about these approaches, and they could get certain guidance on where they should strengthen themselves. Okay, so this is an attempt that we are trying to do, and we use some +2 level mathematics for this, and some basic logical reasoning, and that I believe is very much necessary, minus humanities. I think for any engineering discipline, that level of categorization is extremely important for people to basically approach. So we just want to find out how things are being approached. So I, sorry if I'm repetitive here for people who are there in the previous session. Suppose let us take 2 plus 3 into 5, right? If the answer is 17, if somebody writes us 18 or 16, we can basically train this person with more addition. Right? The error is in the addition. But somewhere there's a mess up in the addition. But somebody writes it as 25, then there's a big conceptual error here. Because it's basically taken 2 plus 3 and multiplied by 5. And we have to now start teaching in this type of an expression, first do multiplication, then do addition. So that's a different level of training that we need to give. That is a very simple example. Now through this exam, if we could get some feelers of what sort of training would be necessary after the student gets into IIT, I think that will be extremely useful. And this is something we are starting now. We'd like to do it for say 5-6 years to come. We'll collect some data, and then based on that, can we come out with an effective guidance mechanism by having these type of exams? So this is something that we are basically attempting. Okay, thank you very much for coming at short notice and trying to spend this time for this. Okay, now this is the third question paper that we are looking at. Now there are 5 rectangular cells, and I am looking at, we have to fill it with 2, 3, 5, 7, and 11, such that the sum of every 2 adjacent cell entries should be a composite number. Prime number is one which we can't, there is no factor for it. For example, 2 and 7 and 11, 2, 3, 5, 7, 11, all are basically prime numbers. But 2 plus 3 is a prime. Plus 2 plus 5 is a prime. Plus 3 plus 5 is not a prime. It's 8. Right? So what we are saying is the sum of every 2 adjacent cell entries should be a composite number. I can't fill it as 2, 3, 5, 7, 11. If I fill 2 plus 3 becomes 5, which is a wrong thing. So I don't want any 2 adjacent cell to become a composite number, to become a prime number. Okay. So this is the overall, this is a question. So how many ways can I fill this? Right. So when we get such type of problem, which is also conceivable, like this, it's not some 100 numbers we are asking to. Enumeration becomes extremely important, right? In research, when you are trying to solve a problem, basically it is solving by induction. We solve certain base cases, and when we solve base cases, very small set. So you're asked to solve a big problem, but you take a small subset of that problem and try to arrive at a solution, and then basically go ahead and make a larger solution. But when you are trying to get to the small solution, at least at that point when you are enumerating, you should be very clear. You should observe everything that is coming out of that enumeration. So that's very, very important. So let us see what's happening. So I have only 5 numbers. So let me just start, enumerating this. Now, please note that two plus 3 is a prime. Okay, and similarly 2 plus 5 is also a prime, and 2 plus 7, 9 is a composite, right? It's not a prime. 2 plus 11 is also a prime. I think this enumeration, if somebody comes out with anything similar to this type of thing, please give 5 marks, because this person now is trying to enumerate. He's not trying to use some vague properties to solve, exhaustively eliminate. So this is one approach of research that we want to look at. Now, obviously from this, we can say that 2 cannot be in the middle. If 2 is in the middle, assuming one side I have 7, the other side I will have either 5, 2, 3, 5 and 11. Sorry, 3, 5 and 11. If 2 is in the middle, right, one side, let me say I have 7. So 2 plus 7 is 9. But because the adjacent cell should be composite number, the other side will be either 3, 5 and 11. In which case, this 2 plus 11 or 2 plus 5 or 2 plus 3 will become a prime number again. So 2 can never be in the center, right? So this we should give at least 2 marks for that 2 can never be in the center. Okay, so 1, 2, 3, 4, 5. So there are 2 possibilities now. 2 can be here or 2 can be here. The remaining thing is, if 2 is here, the only possibility here should be 7, because if I put other 5, 3 or 5 or 11, then I get another prime. So 2, 7 here and 2, 7 here are the 2 possibilities. Okay. After that, I can put all the other combinations. 7 plus 3 is composite, 7 plus 5 is composite, 7 plus 11 is composite, because these are odd numbers, right? Odd plus odd is always even. So I can put any. So the remaining 3 fellows I can put in any combination. How many times I can put 3 fellows? How can I? 3 into 2, 6. So I have 6 ways of organizing this. The remaining whatever 2, 3, 5 and 11. So 3, 5 and 11 I can organize. I can put 3, 5, 11, 3, 11, 5 like that, 6. And again I have 6 ways of organizing. So totally combination is 12. And if they do this, you give them another 3 marks. Okay. Right? So this is the full approach that we need to take. And this basically gives one very good indicator that the candidate has indeed basically tried to enumerate, tried to approach the problem from an aspect of enumeration, and at least that approach is correct, and he has found out something about some observation. But this becomes a very crucial observation. Gives you 70%, you have solved the problem. Right? And then finally, the correct answer. Okay? Are you able to get this? Okay. Now, the next question, Rudra, next question.
If somebody directly writes all the combinations and doesn't describe anything, so what can be done?
You give them 8 marks. At least they have written it. At least they have correctly written it. Give them at least 8. Right? Because that should be some from a research angle, there must be some pruning. If you start enumerating, you will not get, in real research you cannot. Okay. But anyway, we are not using this for any shortlisting or anything, but we are just basically looking at research aptitude. Okay. It's not going to be, but give 8 so that when they discuss later, we are going to give the guides. It's up to the guide and the student to discuss this. If they find it useful, then. But I'll take 45 minutes to enumerate. Okay, next question. So in a wholesale shop, there are 3 brands of pen. Brand A comes with 5. Brand A comes with 5 pens. Brand B comes with 4 pens. And brand C comes with 3 pens. Okay. Totally, we have to buy 122 pens. And at least 1 from each brand. No loose pens. Each brand, and no loose pens. Okay. Suppose I buy 5A plus 4B plus 3C is equal to 122, where A, B, C must be greater than or equal to 1, and they are integers. Okay. So this is a question. Okay. Now, see, first and foremost, where do you start? Right? I have maximum, and there is another condition, sorry. Totally 30 packs is bought. So total 30. So if I buy A from this, A plus B plus C must be actually equal to 30. So also. Okay. So the point is, somewhere we should make a start, which is much closer to this. So I have 30, I have 4 pens, I have 122. So let us say that we have 2 criteria here. How much I have bought from A, I have bought from B, C, total, and at least 1. These are the criteria. Okay. So if I buy, say, so the point is, the clue here is 30 and 4 and 122. This is the most tractable thing. So let us assume I buy 30 of brand B and nothing from A and C. I get a total of 120. So 30 is met, but 120, this is not met, and at least 1 is also not met, because I am buying 0 from this. 0 from A, 0 from C. That means I have to increase this to 122. So how do I increase this to 122? I can remove 1 pack here. That means I can remove 2 packs. The only way to increase 2 in this is to, because there's no loose pens. So you can remove 2 packs. If I remove 2 packs, I get 8 out. That 8, how can I realize with this? I can put 1 5 and 1 3. Okay. If I remove 2 packs here and I say, if I remove 1 pack from this, so if I remove 2 packs, I remove 8. I can put what can I put here? So first is A is 5 packs. I can put 2 A's. So I can remove 20. I can make it 28. I can put 2 A's. Then what will happen? So this is 10. This is 8. I increase by 2. So this will become 122. Tick, but at least 1 is not there. Okay. The other way I can do is I can remove 2 here, and I can put one this and one this. So I can have still 28. I'll put one of this back and one of this back. I'll get 122, and I'll also meet. So this is one feasible solution for this problem. Okay, because 28 into 4 is 112 plus 28 into 4 112, and this is 5 plus 3 8. I'm getting only 120. I should get 112, and this is basically 10. So this will not work. Not 5 and 3. It should be 1 minute. I remove 4 from this. Just a minute. I am only adding 8 here, so it should not be. I should add basically 10. Huh? 1 minute. So what are the things? I've just evaluated. 1 minute. So this is, I can't do this. I have to do 26. I bring 2 more out. So when I make 26, that means I have removed 16 pens. Can I get 18 from this? Yes, I can. I can get 18 by putting 3 here and 1 here. Okay, and that will give me 122 and at least 1 in each. Correct. Then next thing what I can do to get 122 again, I can make this 24. When I make it 24, how much I get out? I remove actually 24 out. So I can basically put 4 of this and 2 of this, which will be 26. Okay. So like this I can keep going. So then it'll, we can easily see 22 and I get 5 of this and 3 of this, right? And this I can go and finally I can come up to 2 of this, and so from 22 how many I'll get 2 of this, and so 22 I can write it out. So 20 I can have 6 of this and 4 of this. So so 18, 16, 14, 13, 12, 10, 8, 6, 4. So 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16. So it will be 7, 8, 9, 10, 11, 12, 13, 14, 16. So I'll have 16, and this will be 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 16 into 5 is 80, plus 2 into 4 is 8, plus 14 into 3 is 14 into 1 minute. I'm just missing it up. 26, 24, 22, 20, 18, 16, 14, 13, 12, 10, 8, 6, 4. So 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 into 5 is 80 plus 8, and this will be 13, no? 5, 6, 7, 8, 9, 10, 11, 12, 13. 1 minute, just 4 into 3 is 12, plus 20 into 4, 80. 30. Correct. I bring down 18, add 7 and 4. So 16 into 5, 80. Wait 1 minute. 8, 88. 14 into 3. Oh shit. Okay. 14 into 3 is 3, 4. This is coming 130. I should get 122. Wait, what is it? Hmm? What? Oh shit. Sorry. 14, 12. So this will be 15 and this will also be 15. Sorry. This will be 30. 1 minute. 7, 8, 9, 10, 11, 12, 13, 14, 15. This is 15 and this will be 30. Okay? Sorry. Correct? So 15 into 5 is 75 plus 2 into 4 is 8 plus 13 into 3 is 39. So comes right. 39 plus 8 is 47. 7 plus 5, 12. Okay. So the total things that we can do starts from here 3 to 15, which is totally 13 combinations I can have. Answer is 30. Okay. Right? 30. 2280 cannot come because at least one I need. So 13. Okay. So what we are trying to basically get out from here is this enumeration capability and the starting point, right? So if I start with 150, for example, then it would essentially take long more time for me to. So what is the actual optimal starting point? So this some way I feel this is the given side 10 papers to read and a given problem. We need to select which paper, right? Somewhere I believe that this is connected to that, right? Where we start, the starting point. I believe that this is connected. We really don't care whether he gets this 13 or not. But if he starts with saying, let us try with this and very close to 30 for B, right? That itself we can give 5 marks for this. And then any reasonable argument coming towards this, we can have the remaining 5 marks about it. Any reasonable argument that you can have. But the answer is too wide, like 100 or this thing, then it's wrong. Okay. Ultimately. Okay. Right. No, this equation again 3 unknowns, no? 2 equations. No, where do you apply? Okay. But anyway, he has to do something like this for sure. See, ultimately, if you start viewing it as an equation, anyway, you have to basically get c greater than 0. It becomes a linear program problem in some sense, integer linear program. Okay. Right. So next question. Yeah, computer is programmed to generate n natural numbers, each lesser than 1000 at random. Okay. So you have to pick some number at random. And what the computer does, it doesn't give 1, 4 like that. It basically gives you, so natural number is essentially starts from 1. Then basically it basically gives you uh, uh, the sum of the digits. For example, 1 to 1000, if 1, it gives you 1. If it is getting 10, it gives you 1. If it gives you 100, it gives you 1. Right? Right? So if it's generating 999, it gives you 27. Okay. Now the question is, we are making a statement that one can definitely find 5 numbers. So you define an n, right? You define an n. In that n, right? You can definitely find 5 numbers which belong to which gives the same answer. For example, if n is 3, I can find If I get 1, 10 and 100, I am having at least 3 numbers which are giving 1. So if I am displaying n numbers, at least 5 of them must give the same answer, right? So I'm picking from 1 to 1000. So if I pick 999 and there'll be only 1999 because I can't get 27 for that. If I pick say if I pick 2 numbers 333 and 900, both will display 9. Right? So the statement is, what is the minimum value of n such that 5 numbers at least will display the same digit or same answer. Okay. You got this question, right? So moment this question comes, the very simple question, actually it's a simple question. Moment this question comes, right? So first and foremost, we go and start classifying ourselves, right? So for example, what are the numbers that will give 1? Okay. Then what are the numbers that will give us 2, 11, 20, right? So we have some 2, 11, 20, say 101, 200, that's all. And 110, for example, then 200. So what are the numbers that will give 3? So we just have to see 3, 12, 21, 30, 102, 111. So if it crosses 5, then okay, it's all set of 5. Like that, we can go. Last one will be C27, 999. So how many can give you 26? That will be very simple. So 899. Any combination of this, 989 and 998. This is 26. How many can give 25? Of course, you can. 25 will be 898. That's the minimum. Sorry, 799 is the minimum for 25. Then I can increase and decrease here. 889. Increase 1 and decrease 1. 898. 979, 988. Then it goes off 997. So these are above 6. Okay. So that's on C1, C2, then up to C27. C1, C2, C26, and C27 are the only things which are only fellows who have less than 5. All the other sets have 5. Okay. Right? Suppose so what the one possibility is, I display all these numbers in C1, there will be only 3 of them. I display all these numbers in C2, there will be only 5 of them. No, in C2 there are 5. So I display all the numbers in C1, there will be only 3. I display all the numbers in 26, there will be 3. All the numbers in 27, there will be only 1. So all C1 is 3, and there is another 3 and 1. In the remaining things, I can display more than 5. So all the other fellows, let me display 4 each. 4 plus 4 plus 4 for the remaining 2 to 26. So how much this comes? So that is to 27 into 4. 2 to 26 is 27, right? 27 into 4 is 108. 108, sorry, 26. Wait, 1 minute, 1 minute. C2 to C25. So 2 to 25 is how much? 24. So 24 into 4, 96, and plus 3 plus 3 plus 1. So 99 plus 3, 102, 103. So I can display 103 numbers such that none of the fellows have 5. Right? I am displaying only 4 from each. That 4 will give me 2, but 5 will not give me 2. So I can have 4 2s, I can have 4 3s, I could have all these. So 103 numbers I can display. I have a counter example. 103 numbers I can display such that the same answer doesn't repeat 5 times. Correct? So 103 cannot be an answer. But the moment I go to 104, obviously I have to include at least one from this. The maximum I can put from C1 is 3, and this from 3 and this one. So the remaining, 3 plus 3, 6, 7. The remaining 103 minus 7, the 96 I have. I'm adding one more. That 97 numbers spread across this 26 buckets, 24 buckets. At least one fellow should have 5. So the minimum value of n is 104. You're getting this sense? Okay. So this is sort of a pigeonhole principle and other things. We will not go into that. Very simple, common sense that we are using to basically get this. So what is that the observation here is that now I am basically enumerating. I have got this 5 here, very clear. I have got this, 5 here. So this 5, so I have to enumerate. I have a reason for enumeration, which is some of the digits should be same. So I categorize the digits. The moment, so in this question, the moment I do this categorization, I must get this 5 marks. Whether I get the answer or not is different. The moment I get this categorization, then we are now looking at this argument that I can still generate 103 numbers such that 5 of them are not same. Right? That should give us at least 2 marks. And then that argument that if I add one more, or this can give even 3 marks, and the other one can give 2 marks. If I add one more, then I get an answer. Okay. So this is for the approach. I'm trying to approach this problem like this, but then there is. Okay. We are getting you are getting feel of this. What we are trying to do with this. We are trying to. We are not interested in the solution. We are at this point. Our analysis is almost up to how do you approach the problem. Okay. Fair enough. It's boring or interesting. Don't say because I'm a director. Really interesting. Okay. Sure. Next question. So this is a very, very interesting question, which I believe will give a lot of insight into how a person thinks. Now this is a rectangle, and it's split into 3 parts. Sorry, it's a square. Okay, it's a square, and P1, P1. This is split into exactly three parts. Now I'm trying to make a quadrilateral by connecting one from S2, S1, one from P1, P2, one from Q1, Q2, and one from R in this. So I can make a quadrilateral like S2, P1, Q1, R1. Okay. Right? So this is the thing. Now how many quadrilateral have areas of distinct value? Okay, this is the question. How many quadrilaterals of areas of distinct value? Now, first and foremost, how many quadrilaterals are possible? Forget the area. 16 are possible, right? One from this, any one from this, there are two possibilities, any one from this, any one. Somebody writes 16, we give 4 marks. Because they have understood the formulation of the problem. Correct? That 2 into 2 into 24. Okay, so that understanding of this problem itself is a very important thing. So somebody writes 16 quadrilaterals are possible. That 16 itself will give you 4 marks. Now, note that this is a square, there is a symmetry here. Right? So at least 8 of them should be equal to another. Just so if they say symmetry 8, give them another 2 marks. Okay? 16 is 8 marks, sorry, 4 marks. And they say 8 because of symmetry. Just say 8, don't give. Okay, then it's like MCQ, right? Just put some number and you get the answer. Okay, because of symmetry, because it's a square, and you are seeing all are equal. These are all, everything is equal. So I connect like this. I just turn it. It is so there can be for one. There will be surely one another which is reflecting. So because of symmetry, and it's a even number, so there should be pairs. Okay, so then that you give another 2 marks for this. So even 8 will come. But you know what the answer is? Just guess the answer. Answer is actually 3. Okay, we'll just work it out, right? So the beauty of this whole thing. So let us say this is P1, P2, Q1, Q2, R1, R2, S1, S2. Okay, right? Now, please note that I connect P1, then I connect Q1, then I connect R2, then I connect this. Correct? Now, for all the trapezoids, all the quadrilaterals, the sum of the internal plus the external area is the same. Well, I am embedding in the same square. That's the crucial observation, right? So you start observing something more than what you have. See, there is one universe set, and you are trying to do something as a subset of this. You can also try to take the other part and solve. So this is in +2 when you do, there is something called proof by contradiction. Suppose not. You know, you would have written half mark will get for suppose not, you should write, and I was taught, right? That's proof writing. Proof writing is very important. You write suppose not, and then say we ran up with a contradiction. So these are some mindsets where you start looking at the other side of the coin. I don't want to look at this quadrilateral at all. I want to look at this part. Now, by doing this, by drawing a quadrilateral, I'm basically getting 4 triangles. One triangle which is connecting immediately here, let me call it small. One triangle which is immediate, but first one here and first one here, or second one here and second one. So this is, let me say, this is medium, and one which is connecting across this is large. So there are 3 types of triangles that I create. Okay, right? Please note that if I have one S, I need to have one M for sure. The next fellow will always be an M. Correct? Correct? So I have SM, and I could have, say, I could have MMMM. Say, for example, M is what? 1 to 1. So I could have M 1 to 1 and 1 to 1, and of course this is 1 to 1. So I could have this thing where all are M's. So I could have M, 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 and what I am having here is SM, and this is L, and this is M. How many such combinations are there? Huh? I could have. Huh?
Three only objects can be formed. One is square, one is rectangle, and one is quadrilateral.
No, here. So in this, we only get triangles here. The other outside part, you get 4 triangles. What are the 4 possible triangles that we can get? One is MMMM, that is one. Another thing is SL, SL. Okay. So these are the 3 possible things. Okay. If I have a S, I need to have an. If I have a S or a L, I could have a S and M. If I have a S, I will certainly have an L, and then the remaining things can be M and M, or if this L and M can also become SLM. Okay, right? So the area of the quadrilateral is not viewed as that; it is viewed as the complement of the remaining area I get, and I could have only 3 different combinations of that. So distinct number of quadrilaterals will be 3. All others will be equal to something in terms of area. So this is a sort of thing. So somebody gets that to from 4 to 16 to 8, you give 6 marks, but from 8 onwards, depending on the argument, you can give the remaining 4 marks.
My case, if I understand this in a different way, like if somebody directly sees this, they can come to a conclusion that one square can be formed inside this by the combinations which are being asked. One rectangle can be formed and one in this same quadrilateral can be formed. So someone can directly write this.
But then they should write a very clear justification. And they should say, why not? See, that's the question. I am getting 3, fine. But why not other than 3? That we should write. 3 is an existential proof. But not more than 3 is a conclusive proof. 3 is sound but not complete. Correct in that sense. So I should also write why not more than 3. This gives me why not more than 3. You got my point, right? Okay. Any doubts? You have a doubt? No, this is very clear. No, if you go to the top, Rudra, can you go to the top? We're very clearly just go to the top quickly. Yeah. For every question attempted, please give detailed explanation on how you arrive at the answers. Okay, just go next very quickly. Satya has come. No, that's right. So we come to the 5th. How many 4-digit numbers less than 4,000 are there such that the product of the first 3 digits from left to right results in the 4 digits? For example, 3113, 3 into 1 into 1 is 3, 2 into 1 into 4 is 8, 1 into 1 into 2 is 2, 2 into 9 into 0 is 0. Right? So how many which are less than 4,000? Okay. So this is a quite tricky question, but again, what we are trying to assess from this is what we are trying to assess from this is basically the ability of the person to enumerate this. Okay. So very quickly we'll just do this. In 0, let us take all the 4-digit numbers. 0 means there should be at least 1 0, and there will be at least 1 0 here. And the remaining numbers, first number can be any of the 9s. So it can be 1, 2, 3. It can be 1, 2, 3, 4. The 4-digit number. So So it should be, it can be 4 possible things, and again there can be 5 possible things, and there can also be no, here there can be 10 possible things. So I can have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and here I could have another 10. Okay. So essentially, but at least one should be 0. So if you just enumerate this, let us say last digit 0. So how do you do this? Last digit 0. So so it can be if the last digit is 0, we can get the total number will be, we start with 1000, 1010, 1020 till whatever till 1100, then 1090, then 1100, like that. So we will basically have totally up to 9999, we will have something like 19 into 9, that is 171 numbers we will have with last digit as 0, starting from 1000. Okay. And with just last digit as 1, I have to have everything 1. So I have only 1, 1111 for this. And 2, 3, 5, and 7 are all prime. So it will be just combinations of 2, 3, 5, 7. It will be combinations of that 1 and that it will be ones and that 2. So it will be 1, 1, 2, 1, or 1, 2, 1, 2, or 2, 1, 1, 2. Similarly, I could have 1, 1, 3, 3, like that. So four combinations, 4 into 3, I'll have 12 of them. Then 4 or 9. So 4 again, I have only 2 combinations. It can be 1, 2, and 2, or, and for 9 it will be 1, 3, and 3. So again there will be 6 combinations here. 1, 1, 2, 2, or okay, sorry, 4. So 1, 2, 2, 4, 2, 1, 2, 1, 2, 4, and we could have. So totally, I can also have 1, 1, 4, 4. So I could have 2 into 2 or 1 into 4. Similarly, 1 into 6, 1 into 9. Okay. So this is, so this will get around 12 combinations, 6 for each, 6 for 4, and 9 for, and 6. It's just going to be, it will be 9 combinations, because I have 2, 3 as 6, and I have 1, 6 as 6. So again I'll get 9 combinations. And similarly 8, I'll have 10 combinations, because I could have 1, 8, and 2 into 4, I could have 2, 4, and I could have also have 2, 2, 2, 8. So totally I'll have 10 combinations here. So totally, if you add this, you basically land up with, you do it for 9,000. So you basically land up with 215, 171 plus 1 plus 12 plus 12 plus 9. You get 215 of them, from which we can remove off. There's 19 per 1000. So from 4,000 to 10,000, we can remove off that 6 into 19. That is for the zeros. So 0, we have 171. This is till from 1000 to 999. Now we can remove off after 4000 onwards. So there are 6 such 1000, and each of them have 19 numbers. And also we can remove of some of these combinations for which starts with 5 and above. So 5115 and 7117 for this in this series, and for the 4 or 9 we have 4114 which starts with 4, and 6 we have 6116, 8118. There's one 4128 also for 8, and 4218. So 6 into 19 plus this 8, this gives you 122 numbers. So the total will be 215 minus 122, which is 93 digits. Okay. So this basically you do by enumeration, but how quickly you can basically arrive at these. So when they start doing by enumeration, because there's no other go for this, that enumeration itself you can give 5 marks, and then they start at least getting some numbers of this correctly, okay, that you can give some 3 marks, and the final answer is 2. Okay. So coming to the last question. So suppose I have x plus 3xy plus y equal to 13. So we need to solve this. What are possible solutions for x and y? Many times, right, if you land up with such type of things, we would like to see that, you know, we get multiple equations from this. For example, one of the things that we can do, 3x plus 9xy plus 3y equal to 39. Add 1, 3x plus 9xy plus 3y plus 1 equal to 40. Okay. Now what this will become, it will become 3x plus 1 into 3y plus 1 is equal to 40. Correct? So certainly, so given that x and y are integers, okay, certainly 40 should be divided by 3x, divisible by 3x plus 1, 40 should be divisible by 3y plus 1. So both are very important, right? So that's the crux here. So I need to get a so 3x plus 1 should be a factor, or negative of a factor that is 1 more than a multiple of 3, right? Because 3x plus 1 should become a multiple of 4, or multiple of 2 to basically, you know, be divisible by this, right? Because y is an integer, right? So 40 must be divisible by 3x plus 1. So the answer for this would be x can be 1, yes, because it is 4. Can x be 2? No, because it's 7. X can be 4. Uh, x is 4, 4, 3, 12. No. X is 10. X can be 0. Yes, because x is 0. X can be 1. X can be 3. 2 it can't be. 3 it can be. Then it can't be 4. It can be 5. 5 into 3, 15 plus 1, 16. No. So this is 0, 1 and 3. And x can be, it can't be 5, it can't be 6, but x can be 13 because it becomes 40. Okay. So this is the thing. This 13 would be a very important observation. Okay. So 0, 1, 3 and 13 are the possible things. But on the other side, x can also be minus 1. So this will be minus 3 plus 1, it will become minus 2. X can also be minus 2 because this is minus 6 plus 1 will become 5. 5 and 40 goes. S can also be minus 3 and X can be minus 7. Okay. Minus 7 is minus 7 and 3, 21, 20. Okay, so these are the possible values of X. And for each value of X, there will be a corresponding value of Y. Because X comma Y should satisfy this. So the total number of solutions that are possible is 8. Okay. So the point that we want to find out here is, this is a completely, if you start enumerating on this, you are going nowhere. Okay. The point is, we need to come to some sort of a point where we can start doing some analysis. And the best way to normally do such type of analysis is to perturb this equation and get to some level where you can do a factorization. And the way I can do a factorization, I can just say x into 1 plus 3y. No, it doesn't work, right? So I need to get to a point where I need to factorize this. Unless I factorize, I can't answer this question. So the moment I have an equation and I have something on the other side, unless I split it into 2 multiplicand and get something on the other, then only I can do some analysis on this. In one of the cases, we had a into b is a prime square. That means then immediately I know a should be prime squared and other should be 1, or both should be prime, or one should be one is 1 and another is prime squared, or both should be prime. So we get that insight into it. So normally when we have such equations, so if this attempt is made, we should give it 5 marks for that. Just an attempt, right? So that I'm trying to basically do this analysis. After that, of course, you do all this logical thing. So this is all, friends. As you see, all these questions are basically using some basic concepts. There's nothing great about those concepts, but how do we put these concepts together and basically come out with an answer, right? And this is all, in my opinion, this is all research is about. Okay, we understand so many fundamentals. You do your basic courses, you do your comprehensive, you read a lot of basic related papers, you have a lot of fundamental things. Now you have a problem at hand, and you know how to put these fundamental things to solve the problem. So this is what we are trying to assess here. No way we are going to use this for a selection or something. But after the student gets in the case of them getting admitted, now we are going to try and give this to the guide and the student and let them have a discussion along with the solution. And will that be either helpful in understanding what a student must improve in terms of approaches? I think that will be a good research guidance. So this is to tap or find out the gap that we need to fill to build a great researcher. So this may take 10 years to find out actually what is inside. We just wanted to start an attempt. So thank you very much for coming today and helping us out in this wonderful, hopefully a wonderful thing. So you will be the alumni batch, first alumni inaugural batch to have helped in this, if this continues for some years too. Okay, thank you very much. I hope it was interesting. I didn't bore you at this point.
Please be seated for a couple of minutes. Please be seated for a couple of minutes. Hi, thank you and sorry for such a long delay. I've shared all the modalities and how to correct the paper and how to find the paper and what are all the answer sheet that will be allotted to you. You can find in the Excel that I'm going to share with you. But before that, you need to go out. There are like six people, six people will be sitting outside. You need to stand in queue. You need to give your name, your roll number and phone number so that they will allot you around 10 to 12 answer sheets per person. Also, I'm gonna share the. Did I share the answer sheet in the group? Okay, so you have the answer sheet in the group as well. Also, there is a video which is going on. The live was also have shared. In case, if at all, if you want, if you have some doubts, you can check with the video and also the answer sheet. That is one thing. And then, if at all, if there is any, if at all, if you cannot find the answer sheet in the folder, you just need to refresh. Otherwise, you need to close the Chrome and then reopen it. The cutoff time is 2 hours from now, or like maximum 3 hours from now. You can go evaluate and then you can post it on the Google form once you evaluate the paper.